Okay, we've got to talk about triangles, and we're going to spend a lot of time doing this. So let's start. Angles of triangles. All right. Sometimes we name triangles by the sides. A scaling triangle means you have no sides that are congruent. So you might have a side like this, side like this, side like this. None of those sides are congruent. Isosceles, you've got two congruent sides. And those hash marks that I put on there are for a reason. They mean that those are congruent. So this one side is congruent to the other side. And then equilateral, you've got all three sides congruent. That's pretty close. Okay, so those that's when you name angles. That's when you name triangles by their side. When you name triangles by their angle, you're talking about the angles. An acute triangle. Let me try again. That looks acute. All the angles are acute, so all the angles are less than 90. In an obtuse triangle, you've got one big angle, right? You've got one big obtuse angle. And then, of course, in a right triangle, you've got one right angle. And then in an equiangular triangle, you've got three angles that are congruent. Okay, so you might have, we can now talk about triangles in that way. We can talk about an obtuse triangle, and you know what I'm talking about, equiangular, isosceles. All right, so let's talk about some theorems that go along with these triangles. The first one that we're going to work off a lot of is this first theorem, and it talks about the sum of the angles in a triangle. And I'm going to show you the sum of the angles with these two lines here. See if I can make them to move. Maybe I won't. Maybe I'll draw my own lines. Okay, so here is this line. That's pretty straight. And here, I'm just going to extend the bottom of that triangle. Okay, so now I'm going to put some angles in here. These lines are bothering me now. Okay, in this triangle, I drew this line on top to be parallel to the line on the bottom. So I've got this parallel line. Let's look at some of these different angles. I know that this angle here and this angle here, those are, you can say it, you're right, those are alternate interior angles. And alternate interior angles are congruent. Okay, so let's find another one. Over here, I've got this angle and this angle. Those are also alternate interior angles, and those are congruent. Okay, so that means I've got this angle of the triangle is actually up here, and then I've got this other angle of the triangle is actually up here, and then don't forget I've got the third angle here, which I'm gonna just color in. So what do all those three angles add up to? That's right, they add up to a straight line. And straight angles are 180 degrees. And it really wouldn't have mattered what kind of triangle I have in here. It's always going to add up to 180 degrees. So we can rest assured, doesn't matter if you have an obtuse, right, acute, equilateral, isosceles, they're always going to add up to 180 degrees. Okay, so now here's a corollary that goes along with this. It's pretty wordy here. but it's saying that if two angles of one triangle, so let's say this angle and this angle, if two angles of one triangle are congruent to two angles of another triangle, so let's say, so this one is congruent to this one, and this one is congruent to this one, then the third angle is congruent to the third angle. This angle is congruent to this angle. Okay, let's keep going. Here's another corollary that goes along with this. One measure of an angle in an equilateral triangle, let's think about it. If this angle is congruent to this angle, congruent to this angle, then x plus x plus x equals the total angles, which we know is 180 degrees. So that means 3x equals 180. I think you see where this is going. So one angle in an equilateral triangle, equilateral, which is the same as an equiangular triangle. I think I was supposed to write equiangular here, but I shouldn't cross it out. In fact, they are interchangeable, because an equilateral triangle is an equiangular. They're always going to be the same. All right. Another corollary. There can be at most one right angle. There can be one right angle or an obtuse angle in a triangle, right? If this, so here's my right angle. If I made another right angle, I'd never be a triangle. There can only be one right angle if this is going to close and be a triangle or obtuse angle. You could never have an obtuse angle and then another obtuse angle. You're never going to be a triangle that way. One right angle, one obtuse angle, and that's it. All right, in a right triangle, let's think about this. In a right triangle, the other two angles, so this angle over here, let's call it 1 and 2. The other two angles must be, let's think. All the angles in a triangle add up to 180. If a right triangle is taken away 90, then the other two angles, you guessed it, they add up to a 90 also. So they are, that's interesting, complementary. Is that an I or an E? Complement. Whoops. My fault. Complementary. All right. Before we get on to this last theorem, I just want to give you guys a couple terms. When you have a triangle and you extend a line out, that line makes this angle, I'm going to call this angle 1. Angle 1, wait a second. Angle 1 is the exterior angle. Okay, then some other angles are formed. This angle, and this angle. Now 1 and 2 obviously are supplementary because they make this straight angle. But 3 and 4 we're going to call these guys the remote interior angles. Those are the remote interior angles. Okay, now that you've got that, here's a theorem that goes along with that. The measure of an exterior angle, so let's say this, the measure of angle 1, in this case, equals the sum of the two remote interior angles. So remember, the remote interior angles are the other ones, not the one that's right next to the exterior angle, but the other two. And that is our exterior angle theorem. And it's not just that. Let me show you something quick here. What if we had this line extended out? This angle here, let me call it angle 5. Angle 5 would equal the sum of the two remote interior angles. Now, if this is the exterior angle, angle 5, then now 2 and 4 are the remote interior angles. Okay, that's it. I hope this helps, and have a great one.